Hi students, this is chapter 6, applications of vector algebra. Example number 6.5. Prove by vector method that sin of alpha minus beta, which is equal to sin alpha cos beta minus cos alpha sin beta. Now I am going to prove this question by old method. Okay, it's a different method. So not in your textbook because this is already in example solution, right? Okay, so now I draw a unit circle around x and y axis. Okay, I mark two vectors, namely two points, okay, namely A and B. So OA makes an angle to x axis is nothing but alpha, and OB makes an angle to x axis that is nothing but beta. Now the requirement of the angle between AOB is nothing but alpha minus beta. Now, I want to find out the angle between two vectors, that's OA vector as well as OB vector, by cross product method. Because why I want to take cross product? In cross product only we have sine, okay, sine theta. So, I want to draw a perpendicular line AM to x-axis, and BN is perpendicular to x-axis. Now consider I vector and j vector are the unit vectors acting along y-axis and j-axis respectively. Now I want to find out the coordinates of A. What is the coordinates of A? So now generally we can write x comma y. Right, but now we want to find out the coordinate of x and y. Just consider the triangle. I draw separately here. This vertex O, this vertex M, and this nothing but A. So this is angle, nothing but alpha. This is horizontal distance, so we have considered x. This is vertical distance, we have considered that's y. And OA is a unit circle, so the radius should be 1. Now using trigonometry ratios, I find cos alpha here. So cos alpha is nothing but adjacent divided by hypotenuse. What is adjacent side here? This is alpha, so this side is opposite side and this one is adjacent side. The biggest length of that right hand triangle or opposite side to the right 90 degree is nothing but hypotenuse, right? So adjacent is nothing but x, hypotenuse is nothing but 1, which is equal to x. So x is equal to cos alpha. Now I am taking sin alpha here. Sin alpha is nothing but opposite divided by hypotenuse. So what is opposite side? Y. Hypotenuse side 1, which is equal to y. So x value gives cos alpha, y value gives sin alpha. Now I can choose here cos alpha, gamma sin alpha. The same way, instead of alpha, we are assigning beta, we get cos beta, gamma sin beta. So this representation, okay, everything you want to write in the diagram manner. Okay. Now, you want to write solution. Consider the unit circle with center as origin, mark A and B on it, and take angle XOA which is equal to alpha, XOB which is equal to beta, implies AOB which is equal to alpha minus beta. Let I vector, j vector be the unit vectors and take along x axis and y axis respectively. X and y axis respectively. Next, the coordinates of the coordinates of A and B are A and B are cos alpha, comma sin alpha, and cos beta, comma sin beta, respectively. Now, I am going to find out angle between two vectors, right? Now, I want to write OA vector. Okay? So now OA vector is nothing but O to M, M to A. O to M plus M to A. I am going to reach OA vector. So like here, OA vector plus MA vector. OM is nothing but orthogonal distance, and MA is nothing but vertical distance. We know that x is equal to cos alpha. So here cos alpha, here sin alpha. But now we are represented in vector, right? So OM vector is A vector is I vector. So this is horizontal unit vector is I. The same way vertically y axis. So J vector acting along y axis. You want to represent cos alpha I vector or sin alpha I j vector. Similarly, so OP vector, which is equal to O to N, N to B. ON vector plus NB vector. The same way, horizontal distance is nothing but cos beta and I vector plus sin beta into j vector. So now these are the two vectors here. Now we have to find out angle between two vectors. Okay, now I took OB vector plus OA vector first. So in this cross product, we want to find out determinant method. First of all, you have to write I vector, J vector, and K vector. Now you have to write only coordinates of OB vector. What are the components of OB vector? Sin beta is again to cos beta first. Next is sin beta. There is no K vector component, so 0. Next, we have to write OA. OA is nothing but what? Cos alpha, sin alpha. Here also 0. Now, we want to explain determine simplification purpose, right? We are taking I vector. See, if we are taking I minor, you want to omit I row and I base column. Just look at this minor determinant to it. Then multiply this primary diagonals and the secondary diagonals. So both are 0. So simply integrate. Now here 2 plus means here minus here plus. Okay, so minus j vector. Now if I take a minor value of j place, now omit j follows rows and j follows columns, and take 2 columns here. Cos beta 0, cos alpha 0, we get the minus. Then multiply this primary diagonal and the secondary diagonal, we get 0. Next, we want to take k vector. Plus k vector is nothing but you want to find the minor value. Just to omit the k follows rows and the k follows columns, we have the minor here. Then cross product of this one. So sin alpha into cos beta minus cos alpha into sin beta. Now simplification this one, k vector into sin alpha cos beta minus cos alpha sin beta. Put in equation number 1. This is nothing but OB vector plus OA vector. Now we have to go for definition, right? So I write this one. By definition wise, OB vector cross OA vector, which is equal to magnitude of OB vector, magnitude of OA vector into sine of angle between AOB. Angle between AOB is nothing but alpha minus beta. So we are write alpha minus beta into what? K vector. So OB vector and OA vector is nothing but unit vector because the radius of the circle, right? So OB, equal, so it means 1. So it will be 1, it will be 1. So remaining sine of alpha minus beta into a vector. This is equation number 2. OB vector plus OA vector. You see, this is first equation and this one is the second equation. OB vector plus OA vector is equal to A vector into sin alpha cos beta minus cos alpha into sin beta. This is OB vector plus OA vector is equal to sin of alpha minus beta into A vector. So the first equation, which is equal to second equation, is sin of alpha minus beta, which is equal to sin alpha into cos beta minus cos alpha into sin beta. This is final question, very important. Okay? Thank you. Friends, this is example 6.6. This especially this theorem, this is known as Apollonius theorem. In geometry in 9th standard, we are studying about the relation AB square plus AC square is equal to 2 into AD square plus BD square. All the geometry, theoretical geometry, 9th standard, 10th standard, we are studying that. But we are going to prove this theorem by vector method. That's all. Okay? If D is the midpoint of the side of triangle, side BC of a triangle ABC, then show that magnitude of AB square plus magnitude of AC square is equal to 2 into magnitude of AD square plus magnitude of BD square. So now I am going to draw a diagram. So this is x-axis and so is y-axis. This is a triangle. This is A and this is B and this is sides, vertex C. Now A is the origin. Okay? And D is the midpoint of BC. So this is given. D is the midpoint of side BC. Okay? So now I took the AB vector is nothing but B vector and AC vector nothing but C vector. Now I want to find out the resultant vector of D. D is nothing but midpoint of these two. So D is nothing but B vector plus C vector divided by 2. So midpoint means you want to take a 2 points, x1 plus x2 by 2, comma y1 plus y2 by 2, the same way. So B vector and C vector plus divided by A2. Okay? Now the solution. Let AB vector which is equal to B vector, AC vector which is equal to C implies A vector which is equal to B vector plus C vector divided by 2. Now I want to find out BD here. What is BD? So generally in ordinary OB vector we can write, AB vector we can write OB vector minus OA vector. So O is origin A, but here according to this diagram A will be origin. Okay? So that's why BD vector we can write AD vector, second point minus first point, AB vector. Instead of O, we are treated as A. Now AD vector is nothing but B vector plus C vector divided by 2 minus AB vector is nothing but B vector. So simplifying this one, B vector plus C vector minus 2B vector divided by 2. Subtracting this one, B vector to minus 2B vector, we get C vector minus B vector divided by 2. Now, what take AD square plus BD square. Magnitude of AD vector square plus BD vector square. So AD vector square is nothing but B plus C vector divided by 2, and this one C vector minus B divided by 2. So here B vector plus C vector divided by 2 the whole square minus here C vector minus B vector divided by 2 the whole square. Now this is nothing but A plus B the whole square, A minus B the whole square concept. So in divided 2 square means 4, there is no doubt. Here B vector square plus C vector square plus 2 into B vector C vector minus. sorry, here plus, plus. Now, this one, C vector minus B vector. So, magnitude of C vector square plus magnitude of B vector square minus 2 into C vector and B vector divided by 4. So, denominators are same. So, now we can add the numerator. Here B square, here B square. So, probably 2B square, 2 magnitude of B square. The same as C square, C square, there are 2. So, 2 into magnitude of C square. This 2 B at C, here minus 2 C at B will be cancelled because we know that L at B which is equal to B dot A. In not product, both are same because of theta is 0. So cos theta, cos of minus theta is equal to cos theta. That's why cos of minus theta is equal to cos theta. Hence this concept L at B which is equal to B at A. Now take to come outside, so we will be magnitude of B square plus magnitude of C square divided by 4, it will be cancelled. So, magnitude of B square is nothing but AB vector, and this one is AC vector divided by 2. In this side we have AD vector square plus BD vector square. So, bring 2 to left side, we will get 2 into magnitude of AD vector square plus BD vector square, which is equal to magnitude of AD vector square plus AC vector square. Hence 2. Okay. As friends, this is example 6.7. Prove by vector method that the perpendiculars, that means altitudes from the vertices. A vertices drawn from perpendicular to the opposite side is nothing but altitudes. To the opposite of a triangle are congruent. So simply we can represent in diagram. So this is triangle ABC. A perpendicular drawn from the vertex to the opposite side is nothing but altitude. Right? Simply here, perpendicular line drawn from vertex B to the opposite side CA. This is nothing but altitude. The same way, in from vertex C, we are drawing perpendicular line to opposite side AB. This is also altitude. Now, we want to prove that these altitudes are concurrent. What do you mean concurrent? Many lines passes through a single point, only one point. Now you see that this is altitude, AB is altitude, B is altitude, and CF also altitude. These three altitudes are meet at a point. This point I noted here O be the altitude. Okay, now we want to prove that these altitudes are concurrent. Okay, now I took first two altitudes. One is A, another one is B. These two altitudes are meet at O. And using these two relations, I am going to prove CO is perpendicular to AB. CO perpendicular line means this is a line. So we know very well lines doesn't change, isn't it? It has two endpoints. Now I am taking CO means it is extended up to CF. So here I am going to represent CF instead of CF. I am going to represent CO or OC. Okay. So now using the relation AD and B, I am going to prove CF is perpendicular to AD. That means there are altitude and as far as these parts are concerned, hence the concept is over. Let's see. Now the proof. Let ABC be the triangle and OB origin. Let AD and B be the altitudes. meets at O. To prove that antitudes of a triangle connect, it's enough to prove it. It's enough to prove it. CF perpendicular to AB or CO perpendicular to AB. Right? Now, I am going to take AB. Since AB is perpendicular to BC, this is AB is perpendicular to BC because this is altitude. So in vector, we have to prove vector mechanism. So AD vector perpendicular to BC vector. So AD represents I took OA. Instead of AD, I took OA. Because of, we have to say concurrent, so the point of concurrency is O. So we want to represent O. So AD is a line, AD is a line, AO also line. But this is a part of the line. Okay. So instead of AD, we took OA here. So OA vector dot BC vector which is equal to 0. Because this is a dot perpendicular. Two vectors are perpendicular, then the dot product will be 0. This is OA vector dot. This BC vector we can write OC vector minus OB vector which is equal to 0. So OA vector dot OC vector minus OA vector dot OB vector which is equal to 0. This is relation 1. Now we have to do another one. So BE is perpendicular to CE. Okay. So BE is altitude. BE is altitude. It's perpendicular to the side of CE. Now you are going to represent in vector format. So BE vector is perpendicular to CE vector. BE I took OB. Instead of BE I took OB here. So this is the vector, both are perpendicular, then the dot product will be 0. So OB vector and CA vector equal to 0. Now this CA vector, we can write OA minus OC, second minus first, equal to 0. Just remember this one. OB vector dot OA vector minus OB vector dot OC vector equal to 0. This is equal to. Now I am using this first equation and second equation. By adding, we get this results. Okay. Now you see. By adding 1 and 2. What is the first equation? OA vector dot OC vector minus OA vector dot OB vector. Now second equation plus OB vector dot OA vector minus OB vector dot OC vector equal to, here right side 0 plus 0, that will be 0. Now this OA vector dot OB vector plus OB vector dot OA vector will be cancelled. Then take this one, OA vector dot OC vector minus OB vector dot OC vector which is equal to 0. Now here dot OC dot OC is common to both sides. So OA vector minus OB vector dot OC vector which is equal to 0. OB minus OA is nothing but BA vector. This one OC vector which is equal to 0. It seems that OC perpendicular to AB. So this is required. Hence the altitudes of triangle are concurrent. Hence the altitudes of the triangle are concurrent. Thank you, students. Hi, students. This is example 6.8. In triangle ABC, the points D, E, and F are the midpoints of BC, CA, and AB. Now, look at the triangle here. This A, B, C. ABC is a triangle. And D, E, F, where D is the midpoint of BC. So, this is BC. So, take the midpoint, name it as D. And E is the midpoint of C. Side CA, name it as E. And F are the midpoints of AB. So, AB is the midpoint of F. Using vector method, show that the area of triangle DEF. Now we want to draw the triangle DEF inside here. Okay, the midpoint, joining the midpoints, we get the triangle. Now, this is triangle. Now we want to find out the area. So, area of triangle DEF is equal to 1/4 of area of triangle ABC. 1/4 area of triangle ABC. Now, so we know very well area of triangle. This is taken by any two sides, whether AB vector cross BC vector or BC vector cross C vector. We can take any two sides the same way. Here I am going to take B vector and AF vector. Before that, I want to introduce here OA vector is equal to A vector, OB vector is equal to B vector, OC vector is equal to C vector, OBD also. You see, therefore, what about the OD vector? OD is the midpoint of B vector and C vector. So, B vector represents B, C vector represents C. So, OD is nothing but B vector plus C vector divided by 2. And OE vector. So, E is the midpoint of A and C. A represents A vector, B, C vector represents C vector. Hence, A vector plus C vector divided by 2. And OF vector, F is the midpoint of A and B. That's right. So, we can write A vector plus B vector divided by 2. Now, I am going to take triangle ABC. Okay. Now, area of triangle DEF. So, I took the first of all, I am going to area of triangle DEF, right? So, area of triangle DEF is equal to half into take any two sides DE and EF. So, DE vector plus EF vector. This is nothing but area of triangle. We want to consider two sides. So, now inside that D, we can write OE minus OE plus EF, we can write OF minus OE. What about OE vector? So, OE vector is nothing but we see here A plus C by 2. A vector plus C vector divided by 2 minus. What about OB? B plus C divided by 2. B plus C divided by 2. Cross OF A plus B by 2. A vector plus B vector divided by 2 minus. What about OE? A vector plus C vector divided by 2. So, A vector plus C vector divided by 2. Now, here CC will be cancelled 1 by 2 is. Then remaining A vector minus B vector. So, denominator is the same. So, take it. Right. Here, A will be cancelled. We get B vector minus C vector divided by 2. Okay. Take these two outside. We get 1 divided by 8. Then inside, A vector minus B vector plus B vector minus C vector. So, we get 1 by 8. Take cross product with the B minus C. So, this is nothing but A vector plus B vector minus A vector plus C vector. Here, minus B vector plus B vector plus B vector plus C vector. We know there is a B vector plus B vector value 0 vector, and minus A vector plus C vector, we can write C vector plus A vector. So, it is changing otherwise it will be plus. So, I write here 1 by 4 into 1 by 2. 1 by 8 can be written as 1 by 4 into 1 by 2. Then A vector plus B vector, I interchange it here. So before that I write here, so B vector cross A vector, then interchanging this one, we get C vector cross A vector. This is nothing but area of triangle ABC. So now this is nothing X side, this is nothing but area of triangle BDF. So area of triangle BDF is nothing but 1/4 of area of triangle ABC. Next.